Yeah, thank you very much. Welcome to my talk today. I'm very happy to give you a little introduction in Bluetooth Low Energy, Python, and how to build a simple project on Linux. A little bit about myself. As I said, my name is Bruno Vollmer. I'm the co-founder and CTO of Biped, which I'm going to talk more about later. My background is in pretty much standard computer science from RWTH Aachen. And if you want to know more about Biped and everything else, you'll find more information on my website as well. Little disclaimer, there will be some slides with some more information. You will find those also in the description of the talk. I've built a little example because we're going to go through some code, which you also find later. And as a little point here, the whole reason for this talk was me going through that journey from an absolute beginner to somebody having built something with BLE. So I'm not an expert. I would say I pretty much understand everything now. It works in practice, but I'm also not part of Bluez or the special interest group, which is doing the Bluetooth standard. So what are we talking about today? This whole talk is about a practical perspective on Linux, Python, and Bluetooth, but there is still some core concepts that everybody needs to understand my examples later. So there will be some basic introduction into Bluetooth, low energy. We'll then go through some code, look at something, and then I'm going to finish off with some practical tips, tools, and pitfalls to avoid so that you don't have to sit there for hours wondering why stuff doesn't work. We won't have in time to go too much into the code example itself. That's why it's on GitHub. We won't have time to go into the protocol details as well. I'm happy to explain some stuff afterwards or answer a question, and there's also no time to go into any kind of communication optimization. Okay, as a little motivation where I'm coming from and why I'm working with this, as I said before, I'm the co-founder of Biped, which is a device for blind and visually impaired people. The idea is basically you wear it over the shoulders. It consists of a camera module, a computer, and a battery in the back. And the idea is that it can detect, track, and predict the trajectories of all obstacles in your environment, and additionally give you also navigational GPS instructions. So basically to tell you how to go from A to B if you cannot see. And how do we do that is very similar to how a parking assistant of a car would work. So if we detect an obstacle in a certain direction, we will play from that direction a sound which indicates the obstacle with a repetition rate to how close that obstacle is. On top of that, we layer the navigational information, and all of that you hear through open headphones, for example, bone conduction headphones, where you can still hear your environment, but you also hear the audio cues that we give you. And when we started working on this 2 years ago, we quite quickly realized that we will need some sort of interface or communication mechanism to configure the device, to work with it, which is not the device itself. So we decided, okay, we need a way to communicate between a phone and the device itself. And if you look at, there's multiple options out there. We decided, okay, we need some sort of requirements. Fairly simple list. It has to be something that we can quickly prototype together to try it. It has to be quite energy efficient because our device is fairly battery restricted. So you don't want you want the battery to be used for something else, for mainly the vision perception processing. And then you want it to be fast because we also wanted to use the device, use the app to display some real-time debugging information. And I mean, it will not come as a surprise what we decided for. It's Bluetooth Low Energy was in the end the main reason. And the question I get at this point is usually why not Bluetooth itself? Main reason being, if you want to work with classic Bluetooth on devices that are produced by Apple, you better have a few legal, lawyers ready and a lot of spare time to prepare this because there's a bunch of legal hoops you have to jump through, while BLE in itself is not at all restricted by Apple. So that's why, including all the other reasons, we decided for BLE. When I then started my journey into BLE, I quite quickly realized there's a lot of information available for implementing. So what I will explain later is there's two sides to the communication in BLE. And what I realized, there's a lot of information and frameworks available to do the side that runs on the phone, but there's not really a lot of information available for running the side that runs on the peripheral. So on the side, in case our device or whatever, a smartwatch whatsoever. And so to get that, to avoid that somebody else has to go through the same struggle and to give a bit of a starting point. That was the basic idea of this talk today. So, as promised, a little reminder of how BLE works and what the core concepts are about. Just to where BLE comes from, BLE is basically a lightweight subset of classic Bluetooth. Classic Bluetooth is what you know, for example, what streams audio to your headphones. And it was introduced in the Bluetooth 4.0 standard, which is governed by the Bluetooth Special Interest Group. It's an industry group where a lot of big companies are part of. And the idea was basically to give a simple communication mechanism to communicate between devices and modern mobile platforms. This also includes laptops, but it was mainly designed for phones. And the main difference here is instead of having an open stream that continuously pushes data back and forth, we have a device that sleeps between communications, and those communications are also designed to be maximum a few seconds long. And that has as a two main side effects is we save a lot of battery, so we can run it on very battery-restricted devices, as well as the fact that through the design of the protocol, our connection and build-up of the connection is a lot faster than with classic Bluetooth. It does have the big downside, though, that we can send only very limited data. One of the few things you need to know within BLE is the generic access profile, GAP, which basically controls how connections and advertising works in Bluetooth. This GAP defines two types of devices, which is a central and a peripheral. Central is here the example for a phone, a powerful device with a lot of battery, and then we have a peripheral, which could be smartwatch, beacon, all kinds of light bulbs, whatever. And the idea here is that through the definition of the GAP, we only allow to advertise and then later on also connect between a peripheral and a central. There's no way to connect between two peripherals, and there is also no way to connect between two centrals. This is important to know. What it does allow, though, is that one peripheral can advertise to multiple centrals at the same time. And that's basically the idea behind beacons, because if you have, I don't know, some smart homes have these beacons. The idea is basically that because you don't even have to connect to them, you can advertise to multiple phones at the same time, and that's how Bluetooth beacons work. The second important definition is that of the generic attribute profile, or short GATT, which defines how once we have found our device we want to connect to, the whole connection process works. So it describes how the two devices can transfer data back and forth. And I think the first important thing to know is that once you have decided to connect, this connection is exclusive. So you cannot connect a peripheral to two centrals at the same time, but you can only have that once. Then what you have is what is called the attribute protocol, ATT, and I'm going to stop with these weird long names for stuff after this, which defines basically how the data is shared between those devices and what the structure of this is. And the ATT basically has two main definitions, and I think those are the most important things to remember from today. If BLE is new to you, a service and a characteristic, where the service is used to break up data into logical entities, and then a service can hold multiple characteristics, and a characteristic is then what actually encapsulates the data, the single data point. So this could be a value, imagine like a heartbeat, a battery value, a small string, or some small array. And this data together is held in a simple lookup table where each of the services and the characteristics have a UUID that in most cases is 128 bits long if it's custom, but the Bluetooth Special Interest Group, because we have BLE is something that is really restricted on all the messages you can send. They also define some standard services, some standard characteristics, and those have a custom 16-bit UUID. So if, for example, you want to build a heartbeat sensor, the heartbeat service and characteristic have a predefined 16-bit address, which is better because then you can send more stuff, other stuff that you want to send. The way it works basically, and I just replaced the names. So basically what we're talking about from now on until the end of the talk is the GATT client and GATT server, which I'm just going to call client and server for simplicity. We're still talking about phone and peripheral, is that the phone initiates the connection and then the server or the peripheral actually holds all the information on what kind of data it wants to share, right? And so this is the important part to know, is that you define the data within the server and then you send it back. It sends it back. In reality, it's a bit more complicated, but I simplified it here. Okay, that's all the concepts you need to know. There's obviously more to it, but for this example, that's all there is to know. At the end of the talk, there's a long list of resources which you can go through, endless amounts of PDFs if you're more interested in this. Now we are here to learn how to do that on Linux with Python. First thing to know is this only works on Linux, doesn't work on macOS, doesn't work on Windows like this. Basic idea here is we have, in this case, for example, a Raspberry Pi, which has a Bluetooth controller. We have Linux running on it, and what we use is the Bluetooth stack that is part of the Linux kernel, which is called Bluez. Bluez implements all that logic I told you about. It also implements a lot of more stuff, Bluetooth classic stuff. And so we want from our application to talk to Bluez to tell it, hey, create a server, whatsoever. We cannot do this directly, but as it is, I would say, fairly common within the Linux kernel, is we have to do that through a communication way, which is called dbus, dbus is a messaging-oriented middleware, which just allows multiple processes, system or user processes in the Linux kernel to communicate with each other. And the basic idea is you put a message on the bus, and then some other processes can pick that message up and do whatever they want with it. Little important thing to know, because that's what's going to pop up in the examples later on quite a lot, is the concept. The three important concepts within dbus are service, object, and interface. Basically, service is used to wrap everything. The object is actually what is owned by the process, and then the interface is what an object adheres to, so it's a method, a signal, or a variable. Okay, and so this is how it would look in code. I mean, this is strongly simplified, but so we're defining here the descriptor class. A descriptor in the context of BLE is what, every time you have a characteristic, you have a little text which describes what this characteristic is about. That is basically what the descriptor is. And so we're extending the dbus object, and then the object in itself then implements the dbus property interface, which is used for Bluez to tell what kind of properties the descriptor has. Okay. I was not sure if I should do a live demo or not. Many people told me not to do it because it's probably going to break. So you will just have to trust me. The code worked before. I can also showcase it afterwards. But I'm not going to do the live demo, but we're just going to go through the code. Anyways, the demo would have been pretty boring because you just see some terminal output. Before I go into this, general idea is this is one way to design it, right? This is my way that worked for us. This is the simplified version of this. I'm pretty sure there's multiple other ways to do it. In our setup here, what we have is we have our main process, which is super simple in the example, but basically this holds all the logic that is supposed to do something with the data. Then we have the BLE process, which initiates, sets up our server, tells the server, tells Bluez how how our GATT server should look like, what characteristics and services we have. And then we basically have, the phone interacts with Bluez, but then interacts indirectly with those parts so that we can then communicate them back, very classic, with queues, right? This is one way to design this. The idea is pretty straightforward, and I think the important thing to know is just that the whole BLE process, that is based on the dbus event loop because it's asynchronous, and so the idea is basically that we use callbacks and queues to get that into play. And so if we look at our code, this is the main function, right? This is fairly straightforward. The only thing we're basically doing is we're creating the queue, we're then creating the process, we're starting it, and then the only thing we do is we have a while loop going on and on, just checking if there is something within the queue. That would be the place where you place all kind of logic, whatever you want to do. Then we have our BLE process, and here I think the important part to know is, so this is where we create with all the dbus important things, and then we create the service manager, which is the interface which implements the interface where we actually define our GATT server, and then we create an advertisement. And here, I mean, you remember what I showed you about the objects, which then implement interfaces. And so here we have the interface, which is once again the properties interface, which then gives all the information that, for example, our advertisement has. And this is a bunch of stuff that advertisement in BLE allows you. I mean, we've put some fake manufacturer data. It's the service UIDs that we actually advertise. In this case, we just have one service which we advertise, a name, and all kinds of other things that are not important right now. So we create this advertisement, and then the whole wrapper around the thing is what is called an application here. And so the application, once again, is a debug object. And the important thing here to know, the function we're overwriting is the object, the get managed objects function, which just returns like every part, like every service, and in every service it returns every characteristic, and within every characteristic it returns every descriptor. And that's basically all it does. And then the interesting part comes, this is where we can now create custom services, where we add custom characteristics, and we can add them to the application. Add them to the application, initialize the advertisement, register the application. So everything has to be added before we register the application, and then run our blocking call here. And the interesting part is in those 4 functions which we override, because this is where the callbacks come into place and the main loop. So every time somebody writes, for example, to a characteristic, we will then have this function called where, for example, we do something super simple, which is put that written value into the queue, and you can do whatever you want with it. Same goes for the read value, where at the moment we just set a default value to each characteristic. We just return that. And I think the important thing to notice here is that when you have what is called notification within Bluetooth Low Energy, is where you notify the other side, hey, I've made a change to that peripheral, to that characteristic. That is based on a function which is continuously called. So what I'm doing here is every 10 milliseconds, I'm calling this input queue callback. And so that would be one way to implement the fact that you have this input queue, where from our main process, we can just, whenever something's ready, say, hey, write that value. Then you will have to build some logic that the service gives it to the right characteristic. But in the end, in this function, you can then check, hey, is there a new value available? If yes, then we'll just set that value so that on the next read it also works. And we set the properties changed, which will indicate to the other side, hey, there has been something happening. And that's basically the core idea of the whole project. And so if we go back to our presentation, I want to finish off a bit this with like some tips, tricks, and tools. Because I found especially, I mean, with a lot of other things you can do with Python, there's a lot of examples, tutorials available where they show you, okay, this is something, how you can do this, and this is this, and I found this was not the case here. And to avoid being you in the same situation as us, where we're completely confused what is happening and we don't really know how to debug this, this is basically the idea here. The most important tool, arguably, is Bluetooth CTL, which is your command line interface with Bluez. So basically, that comes with Bluez. So once you have Bluez installed on your Linux machine, which all the standard Linuxes have by default, you can use Bluetooth CTL to do all kinds of operations with Bluetooth. You can do something as simple as powering on and off your Bluetooth, but you can also do stuff like scanning for devices and so on. And you can actually create, for example, a GATT server just from the command line. And this is important to know because Bluetooth CTL also just uses dbus. And the idea here really is that basically everything that Bluetooth CTL can do, you can do in your application, because once you've run Bluetooth CTL and in the second terminal window, you turn on the dbus monitoring, which you have to tune a bit so that you don't get all the dbus messages, but just the ones you're interested in. You can actually just see what Bluetooth CTL does and then try to replicate that in your application. So it's basically here, for example, when we wanted to implement some pairing logic where you want to have, for example, ask for a pin or something. I don't know, when you connect to a car, Bluetooth, you have this always. Then what we just did is we replicated that behavior in Bluetooth CTL, looked at what it does under the hood with the dbus monitor, and then had this as a starting point on where to attack this on the application side. If you want to go a bit lower level, deeper into it, you use a tool called BTMon, also comes with Bluez. And it's basically your monitoring infrastructure to show you really the low-level HCI traces. First warning, it's quite extensive. So once you have a connection with a device, this will span hundreds and hundreds of lines within seconds. And so this is only, I would say, usable if you look for something specific. This came in handy for us when we were especially looking on connection stability. So we had some problems with iOS being quite unstable with our device, while Android was working fine. And so then we looked at the logs and see what could cause that. And this is always good to have as a backup to look into this. And then I just wanted to give some ideas on like what could be possible problems and what could be possible solutions. Biggest problem in the end is like, it's not a joke, actually restarting the Bluetooth service on your machine helps, I would say, in 80% of the cases. Once you have figured that out, what I think the biggest thing was for us was, okay, the advertisement wasn't even showing up on our external device. So you have these test apps, right, which just show all the BLE stuff in your environment. You have it running, you have the app, it's not showing up. That would be basically something where I would monitor the dbus. Because dbus won't tell your application directly, hey, there's something wrong, there's no exception going to be thrown, but you can have a look within the logs, and most of the times you just search for error or something similar to that, and then you will find, okay, have you forgotten to define something, you miswritten something, or you did something wrong. The second thing I already told is basically once you have this a bit more complex setup between an app and a device, and there is some bug in there and you don't know which side it is, what I would usually just do is take one of those test apps available for Android, for example, lightbulbs, or iOS has also some, and then you would just you could connect those to your device and then write custom values to to each of the characteristics. You can see if the definition of the characteristics is correct and so on. And then finally, if the communication is unstable or certain messages don't arrive, I would just look at the Bluetooth monitoring. And then some pitfalls at the end. I'll just quickly go over it so you can hear all of them. Really be cautious about the fact that there is some max sizes defined for different parts of the messages sent, especially for the advertisement, for example. It is not possible to advertise 2 custom services at once. We found that out the hard way because there's not enough space in that message. Second thing is, iOS and Android do not behave exactly the same on everything. They have both their own detailed implementations of BLE, which I guess they didn't talk to each other, but they behave differently. And the big thing here for us that was different is on Android, we do not actually pair the device. We just have the communication. It works fine. And on iOS, if you do not pair, the connection is super unstable. I cannot tell you right now what the reason is, but for example, there's something where you have to see how the different platforms behave, and it also is not enough to just check one or the other. And finally, there are some connection parameters for iOS, but that is also part of this. Thank you very much for listening. I hope it was clear, and I'm open to give.
Okay. Thank you so much, Bruno. I'm going to read out some questions on Slido. So, is there any hope that Bluetooth on Linux will get better in the future?
I mean, I have to say it's. I'm a macOS user myself on the computer side, so. But I guess they're actively working on this. So what you can see is, for example, Ubuntu is always quite far behind on the Bluez version. So there is a lot of newer versions available. So I would say if you're really annoyed by this, check out their newest, the newest Bluez versions. Update them manually. I mean, I'm not taking any responsibility if it breaks something, but generally I would say they're actively working on this, and they have a very active developer community on Slack as well, if you're interested in this.
Cool. Next question. If BLE isn't used for any long connections, then how would you, for example, flash firmware to a device? Or is it okay, but just not recommended?
So yeah, that was one of the problems we had. I mean, yes, I would not recommend using BLE for anything data intensive like this. What we do is basically that the person over BLE indicates to the device, hey, connect to the Wi-Fi. Then we do the update over Wi-Fi, and then we disconnect the Wi-Fi again.
Great. So Martin Hecker, who's sitting to my right, would like to know, can one device or computer be central and peripheral at the same time to ease development?
I don't think that's possible, but I would not be 100% certain. I think really what I've seen so far is that you would really want, like a big problem with Bluetooth is that you really want to try out the actual connection to debug it. So as I said, for example, what we did in the beginning was we worked a lot with Android only because I assumed foolishly that it would behave the same on iOS, and then I tried it on iOS. Nothing worked, and it took quite some time to adjust it and to do some custom logic. And I would recommend trying it directly. And I would say it's not possible, but I'm not entirely sure.
Okay. So another question. You mentioned stability issues with iOS. Was it just a rebooted issue, an Apple issue, or a you issue?
It was a combination of an Apple and us issue. So the first thing that that is not, I feel like that could be more proactively communicated by Apple is the fact that Apple requires you to use, like they say, okay, within a BLE connection, there's some parameters you can set. And they actively say, if you don't set those, we don't guarantee anything. And so what they do is they would just randomly cut the connection and so on. Once you set those parameters, there was also a bug from our side, which we then found through BT1, so that's why I'm putting it here, but I would say it is a half-half.
Okay. James wants to know, if I wanted to try this at home, do you know any good starting device that doesn't require VC money?
Yeah, I mean, in the end, but really the point of this was, if you want to try this at home, take a Raspberry Pi and do it, right? That's the whole point of it, is that, I mean, I think be that the reason why nobody, or the way there's less known information about this is the fact that mostly this is done by big companies that produce those peripherals, and it's not something that a lot of, I would say, like people want to do in their free time or open source is there because, yeah, there was not a lot of interest. In our case, it was a special case, right? But I would say super easily try it, take a Raspberry Pi at home, do it, and then it should be fine. Yeah.
Do you have also experience with ESP32? Do you have also experience with ESP32? Because
the question was if I have experience with ESP32. I mean, I personally have not with this, but I would say this stuff should be valid. I mean, I wrote down the version, but as long as Bluez is part of the kernel, which I guess it is in this case, but I'm not sure, right, then it should work, right? This is specifically targeted toward Bluez because Bluez is the most used Bluetooth stack within Linux. But I would assume that because their way to implement the GATT server is following the specification, everything else that would implement like an alternative driver, and if they follow the same specification, the idea would be the same. I mean, the stuff like how characteristics and services work, they're predefined, so there's not a lot of room, I would say, to do this differently.
I think there is also not much room between Android and iOS implementation.
Fair point, fair point. No, fair point. I would say, yes, you're right. It's probably still not going to fit exactly, right? Also with the naming, the debug, I mean, you saw with debug, you have to give a specific path always, right? The naming will probably not fit because they will probably use another naming.
Okay, sorry, we have to stop now.
Yeah, but you asked me later as well.
Okay, thank you everybody for your participation. Thank you again, Bruno.